Welcome to the 7th lecture of Software Quality Assurance. Today we are beginning the second phase of this course. This phase constitutes the discussion related to software quality assurance and different life cycle activities in software development. We will discuss the importance, impact, processes, and techniques of software quality assurance as they relate to different activities in the software development process. This is an important phase, this is an important area because we have to improve the software quality in every activity. We have to remember that quality is needed, or importance to quality must be given in every activity of software development. We cannot expect that we don't pay any attention to software quality, and at the end of the phase, at the end of the project, we'll get a high quality software product. That is not happening. If we want high quality software product, we must put quality in from the beginning. We must perform all activities so that quality is of great importance. What we will do now is we will start with software requirements, and we will take each activity as we go along. Requirements form the basis of all software products and services. And in this lecture, we will talk about what requirements are, what kinds of requirements there are, what are the issues with requirements, some of the problems with the requirements. And we will talk about requirements engineering process, which enables us to systematically determine the requirements for a software product or for a service that is based on software. Directly, I would say that requirements must be of high quality. We must document requirements which meet the real needs of users and customers. Many times we see that problems in the product are because that the software requirements are not of high quality. And as a result, the later activities in the development cycle are also affected negatively by the poor quality of the requirements. So what is a requirement? Requirement is something required, something wanted or needed. And the term software requirement would include both the wants and the needs of customers and users. And I'm not going to go into discussion of the difference between the two, because that's going to take me a little bit off track. And I'm going to continue talking about software requirements. But before we do that, I would like you to remember that we are discussing requirements with reference to quality assurance and management of quality assurance. So for everything we discuss, every item, every concept that we discuss in requirements, try to associate that with quality assurance. In the last 6 lectures, we had formed a basis of what software quality assurance is. We have a good foundation already, and now we are going to apply some of those concepts to requirements and to design and to other activities, and we are going to learn more concepts as we go along. But what I would like you to do is to think about quality assurance as we proceed with these different life cycle activities, and try to associate every new concept with quality assurance. How is quality associated with this? How is quality affected by this? and how can we improve the quality of this particular activity or this particular work product. The importance of requirements is such that the hardest single part of building a software system is deciding what to build. No other part of the work so cripples the resulting system if done wrong. No other part is difficult to rectify later. These are words of Fred Brooks, and how true. Now let's see what software requirements are. Software requirements are a complete description of what the software system will do without describing how it will do it. And so in other words, we can say that requirements or software requirements capture the external behavior of the software product. Software requirements may be stated at different levels of abstraction. They may be abstract statements of services and or constraints. They may be detailed mathematical functions. They may be part of bid of contract. They may be the contract themselves. And they might be part of the technical document which describes a product. And so the level of abstraction varies from project to project, from domain to domain. And both requirements engineers and the people responsible for requirements writing have to understand this. And lot of quality assurance aspects are then hidden in the level of abstraction of requirements. For example, abstractly stated requirements can be interpreted differently by different people. While if you have detailed mathematical functions, then their misinterpretation is reduced, and the chances of misinterpretation are significantly reduced. So it is important that we fully understand the requirements, at what level of abstraction they have been written, and how they can have an impact on the overall quality of software product. The IEEE definition for software requirements is it's a condition or a capability that must be met or possessed by a system to satisfy a contract, standard, specification, or other formally imposed document. And so with this, we have a binding definition of what software requirements are. And this definition can definitely help us in the quality assurance perspectives. Just like we talked about sources of or origins of defects, what are the sources of requirements? Requirements have basically 4 kinds of sources. Number 1, the stakeholders. These are people who are affected in some way by the system. Stakeholders describe requirements at different levels of detail in different levels of abstraction. Then there are documents. They also contain information about the existing system, about the application domain, and they also contain information about what is needed in the new software system. And then you have the existing system. If it's a manual system, there are certain ways of performing things, and if it's an old computerized system or partially computerized system, then that system would also be a source of information, source of knowledge about the future software product. And then obviously then there is domain and business area that has to be understood well. If domain or business area is not understood by the requirements people, by the designers, then there are many possibilities that they will not be able to build requirements or designs accurately. And then that would reflect in poor quality of software poor quality of software products. Let's spend a couple of minutes on talking about examples of requirements, and I'll briefly state them. You can find them in any book on requirements. Example number 1 is the system shall maintain records of all payments made to employees on account of salaries, bonuses, travel or daily allowances, medical allowances, etc. This requirement obviously relates with some sort of payroll software system. The second requirement which I'm going to read is the system shall interface with the central computer to send daily sales and inventory data from every retail store. And this requirement deals with or refers to a software system in which there is a central computer and there are a lot of retail stores which send daily updates to the central system, which then maintains the total sales performed in one day in the entire company. So let's look at another requirement. It reads, the system shall maintain records of all library materials, including books, serials, newspapers and magazines, video and audio tapes, reports, collections of transparencies, CD-ROMs, DVDs, etc. This requirement relates to a library software system, and start thinking about relating the quality of these requirements in your mind. What is the quality of these requirements? Are they ambiguous? Are they complete? And we will see what quality attributes are of quality assurance as they relate to requirements. Now let's talk about kinds of requirements. In the literature, requirements have been classified in many ways. I've picked up 5 of them. So I can say that requirements are of 5 types, or 5 kinds: functional requirements and non-functional requirements. These are 2 main types of or main kinds of requirements. Then there are domain requirements, then there are inverse requirements, and the 5th is design and implementation constraints. Let's talk about each one of them. Functional requirements are statements describing what the system does, so they capture the functionality of the software system. They can also be interpreted as statements of services the system should provide, which can consist of reaction to particular inputs or behavior in particular situations. So in other words, they can be thought of as, what would the system do if I give this input, what output it will produce. And also that in certain situations, without even having a formal input, how would the software system behave? And this deals primarily with those kinds of software applications which are based on conditions of time and sensor softwares which observe things which are not really direct inputs. Sequencing and parallelism are also captured by functional requirements. Sequencing and parallelism are very important part of real-time systems, where it is important to note which events happen before other events. And there is a sequencing concept, and there are certain things which can be executed in parallel, and for that we can have multitasking and we can have parallel computing availability in the hardware also, and that depends on the application domain. Functional requirements also capture the abnormal behavior, that is the exception handling, and functional requirements document these abnormal behavior which is not the main path of the software execution, but if an error occurs or aberrant data comes into as input, the exception type of exception handling is also part of the function requirement. Most of the effort is devoted to understanding and recording functional requirements. The second type of requirements that we talked about was non-functional requirements. Most non-functional requirements relate to the system as a whole instead of individual requirements. They collectively influence the system. They include constraints on timing, performance, reliability, security, maintainability, accuracy, the development process, and standards. Now you should note here that many of these things that I've just mentioned are some of the quality attributes that we have seen. Together they are more critical than individual functional requirements. They capture what is known as the emergent behavior of the system because they, as they relate to the system as a whole. These non-functional requirements capture the quality assurance aspects of the system, and software engineers and requirements engineers must pay attention to non-functional requirements because these need to be built into the framework of the software product. Otherwise, the project will not be acceptable to the customers and users. For example, if an aircraft system does not meet the reliability requirements, it will not be certified as safe. If a real-time control system fails to meet its performance requirements, the control functions will not operate correctly. And even if it has the functionality, the system will be unusable and would be thrown away by the customer. Non-functional requirements are of three types: product requirements, organizational requirements, and external requirements. We'll briefly touch upon each one of them. Product requirements are usability requirements. They can be efficiency requirements, reliability requirements, and portability requirements. And efficiency can be further categorized as performance requirements or space requirements. Now you can see that many of these areas relate directly to the quality aspects that we have so far studied. As an example of these requirements, let me quote just a couple of them. For example, the system shall allow 100,000 hits per minute on a website. Now this is an example of product requirements. The system shall not have downtime of more than 1 second for continuous execution of 1,000 hours. Remember this? We had something like this when we were talking about reliability aspects of quality. Then we take up second type of non-functional requirements, which are organizational requirements. Organizational requirements are standards requirements, implementation requirements, and delivery requirements. These deal with the aspects of the organization of both the software development side and the user side. Then this third type of non-functional requirements are external requirements, which are interoperability requirements, ethical requirements, and legislative requirements. The legislative requirements consist of or can be categorized as privacy requirements and safety requirements. increasingly software is being controlled by and directed by the legislative requirements of not only one country but multiple countries as we grow, as we increase our businesses into international markets, and as global software development has become a real phenomena. The example of external requirements, I would quote here a couple. The system shall not disclose any personal information about members of the library system to other members except system administrators. Another example would be the system shall comply with the local and national laws regarding the use of software tools. And so these are examples which are increasingly becoming part of the contract for software development. I would like to make a few observations on non-functional requirements. Non-functional requirements are written to reflect general goals for the system. For example, ease of use, which is a goal, recovery from failure is a goal, and rapid user response. And so all the three that I've mentioned are goals. These things are not quantifiable. These things are not quantified, although they are quantifiable. And whenever requirements are written, or whenever anything is written as a goal, there is a possibility of misinterpretation, because goals are open to misinterpretation. Objective verification becomes difficult. And there is another point which has to be remembered, is that distinction between functional and non-functional requirements is not always very clear. So it can be one requirement can be considered non-functional in some cases, but if the domain changes and if some more information is added to that requirement, then the requirement can move from non-functional to functional and vice versa. So it is very important for requirements engineers to understand the application domain very well, and understand the impact of misinterpreting the type of requirement. We should strive to write non-functional requirements in a quantitative manner as much as possible, which is not always easy for the customers to do so, because customers would like to say, I want this product to be used easily, but what that easily means is not really clear. And for some goals, there are no quantitative measures. I can say that one of my goals is, one of my wishes is that the software should be easy to maintain. That is, it has high maintainability. But how can I quantify that? Very difficult, right? So even for those things, we have to develop some understandability between the customer and the vendor, that what would maintainability mean. However, goals are a good way to document the wishes, document the desires of customers. And they can be taken as mentioning the priorities of the customers with respect to the expectations they have for the new software product. The chances of conflicts within non-functional requirements are fairly high also. That is, there is possibility that one or more, the two or more functional requirements would have, two or more non-functional requirements would have conflicting goals, because information is coming from different stakeholders. For example, different stakeholders can give different response times or failure tolerance levels as examples. And these are the two things that are directly going to impact the quality of the software product. Some negotiations must be done among different stakeholders to achieve an agreement in these situations. That obviously when there is a conflict, there needs to be conflict resolution, and conflict resolution can only be achieved by negotiation. Non-functional requirements should be highlighted in the requirements document so that they can be used to build the architecture or framework of the software product. If these requirements, that is non-functional requirements, have been fully understood and included in the requirements as well as in the software architecture and design, then we can be confident that we will end up in a high quality software product. The third kind of requirements that I'd mentioned were domain requirements. These are requirements that come from the application domain and reflect fundamental characteristics of the application domain. They can be functional or non-functional. These requirements sometimes are not explicitly mentioned as domain experts find it difficult to convey them. However, their absence can cause significant dissatisfaction. This is because that domain experts assume that basic knowledge about domain is so easy and so common that everyone who is working in that domain must have it. And so sometimes they forget to mention some very basic but fundamental things. And as a result, if those things are not included, it really increases the dissatisfaction, and it ends up with a very negative impression of the software development company. Domain requirements can impose certain strict constraints on solutions. This is particularly true for scientific and engineering domains and some of the medical science and other very specific technical domains. These domains have their own complicated ways of doing things, and that can restrict the solution that a software engineer or software designer can think of. So properly documenting domain requirements is a very important part of having a high quality requirement set and also high quality software product. Domain specific terminology can also be very confusing, and one of the important things that every senior software engineer would give you is that requirements engineers as well as designers must have good domain knowledge. And obviously it is not going to come on the first day. They have to learn about the domain, and they have to work with domain experts to get necessary knowledge about the application domain. Otherwise, they will not be able to perform their tasks as software engineers in the best possible manner. The fourth category of requirements was inverse requirements. They explain what the system shall not do. So these are like negatives. These are interesting requirements because many people find it convenient to describe their needs in this manner. And especially with the user interface, many people say that, don't put red color in it, or don't put yellow color in it, or don't put this set of pictorial data on it. And so they convey their likes by conveying their dislikes. And these requirements indicate the indecisive nature of customers about certain aspects of the new software product. And so if you, as software engineers, you will run into situations like you have selected a color and the customer would say, I didn't ask you to select this color. And what the customer had actually said was, don't use red and yellow and brown. And with that kind of statement, you were open to using colors other than red and yellow and brown. But the customer forgot to mention that, yes, purple is also not acceptable, or the purple is not very likable. And so there is an indication of the indecisiveness on part of the customer on many things when you see these inverse requirements. But these can also be used as what is known as the process of elimination. That, okay, from a large set of colors, you have eliminated 5 or 6, and depending on the kind of project, you have a limited set left with you to use in the user interface design. And so they are also part of requirements. They also appear in requirements all the time. Then you have design and implementation constraints, which are the last kind of requirements that I've chosen to discuss. These are development guidelines within which the designer must work, which can seriously limit design and implementation options. Typically, what we say and what most of the research would have you believe is that requirements shall not have design and implementation constraints as a rule. However, that same literature would point out to the fact that because of some other conditions, because of some other constraints which are external to this particular project, these design and implementation constraints have to be included in the requirements document. And they are somehow going to impact the quality of the overall quality of the software product. These requirements can also have an impact on human resources. And I'll talk about this in 1 minute. The reason design and implementation constraints can limit the options on performing the performing the design for a solution is that you may be asked to only work with a particular technology. You may be asked to only work with a particular language because of the interoperability conditions, because of the interface with existing software applications on the customer's side. The new application may have to use the same database, while better database management systems would be available in the marketplace. But since the customers have difficulty in the management of multiple database systems, the conditions would then be imposed by the customer to use a particular design or implementation language or tool or database. And so this can have an impact on the human resources. For example, they would say that the customer would say that we want to use a database package A, and you have won the contract, and when the project is about to begin, your expert in that area decides to take another job, or decides to go for higher studies, or move to a different city, or whatever, and leaves the company. Now you're left with the situation that you have to hire a new person, and hiring a new person immediately have consequences. It has consequences. The person may not be available in the market. You may not be able to convince the people working from in other companies to go and to come and join your company, and this may delay the start of the project. This may delay the completeness of the project. So there are a number of things that can happen with respect to focused and narrow design and implementation constraints are imposed. This was a brief introduction of requirements, and now we will move on to the requirements engineering process and see what requirements engineering process is, and what are the different activities, what are the different sub-processes within each of them, and then we will continue our discussion. Now you are seeing a chart which shows you the requirements engineering activities. The major activities that you can see here are requirements elicitation, requirements analysis and negotiation, requirements specification, requirements validation, and you also see that user needs, domain information, existing system information, regulations, standards, etc. are being fed into the requirements elicitation activity. And requirements specification activity is producing a requirements document which is being then validated and ends as an agreed set of requirements. Now let's take each one of them, each one of these major activities, and see what their role is. I cannot go into detail because these are themselves very large processes, and if you are interested in requirements engineering, then that's another course. Requirements elicitation is the process of determining the system requirements through consultation with stakeholders from system documents, domain knowledge, and market studies. You have to do all of them for large projects. For small projects, the business application, the business domains are smaller. You don't have to do market studies, but you still have to talk to the stakeholders, and you still have to read necessary documents. But you also must get familiar with the application domain. Requirements acquisition or requirements discovery is the main thing or main activity in requirements elicitation. So you have to uncover the real needs that we talk about all the time, the real needs of the customers. They have to be discovered, they have to be found, they have to be acquired by the requirements engineers. Requirements elicitation is the process which does that. The second major process within the requirements engineering activities is the requirements analysis in negotiation process. Understanding the relationship between various customer requirements and shaping those relationships to achieve a successful result is part of the analysis activity. And this analysis can be done while we are eliciting the requirements and should be done once a set of requirements have been elicited, have been informally gathered and informally documented. When you analyze these requirements, you will notice that some of the requirements have conflicts with each other, or some of the requirements are difficult enough to be postponed for a later version, or some of the requirements cannot be implemented because of complexity, because of other things. So negotiation among different stakeholders and requirements engineers have to be performed. This is the activity where you would prioritize requirements and decide which requirement has higher priority over other requirements. You need to tackle incomplete and inconsistent information here, because you are performing both the analysis as well as negotiation. The analysis would have to be based on these things. The inconsistencies have to be found, and incompleteness of the requirement set has to be found. And also, if there are ambiguities within the requirements, that has to be tackled here. Some analysis and negotiation needs to be done on account of budgetary constraints. Just as I mentioned earlier, that the cost of implementation of some of the requirements is so high that many times you don't even need an analysis. You would immediately know that such and such requirement would or cannot be possibly implemented in the time frame that we are talking about. So negotiation along with those lines with the customer would have to be done, and those requirements would then take the lowest priority levels and would be done in either later release of the software or dropped altogether. So requirements analysis and negotiation is a very important and very critical activity within the requirements engineering activities. Actually, analysis is the requirements of software engineer. You have to be a good analyst to be part of this profession. The third main activity that you saw on the screen was requirements specification. It consists of building a tangible model of requirements using natural language like English, and some sort of graphical notations. These graphical notations are usually consistent of special purpose languages that document software requirements and designs. For example, unified modeling language would be one that comes to the mind immediately, because that's a de facto standard now. But there are others available also. And so specification includes first building a tangible model, and secondly building a representation of requirements that can be assessed for correctness, completeness, and consistency. And these things would then be checked in the validation process that we will see in a little while. The requirement specification results in the production of what is known as the requirements document. This is a very important document, and it contains detailed descriptions of the required software system in form of software designers, developers, and testers are the primary users of the document. However, the technical staff on the customer side also use a requirements document, and sometimes the requirements documents are used as the technical contract between the customer and the vendor. So all of these things that we are talking about are in terms of software quality assurance, that each of these activities that I'm mentioning are related to software quality assurance. Software quality assurance has to be part of each of these processes and even sub-processes within these activities, within these processes. The fourth major process that you saw on the screen was requirements validation. It involves reviewing the requirements model for consistency and completeness. Here we have direct quality assurance. This process is intended to detect problems in the requirements document before they are used as a basis for the development of the software system. And so you saw the agreed set of requirements that has to be after validation has been done of the requirements document. Requirements need to be validated for consistency, testability, performance issues, conformance to local and national laws, conformance to ethical issues, conformance to company policies, and availability of technology. And these are all directly related to quality assurance, as we have talked about. Now, these were the four processes or activities that you saw on the chart. There are other things that must also be mentioned, and one of them is requirements management. Requirements management involves identification, control, and tracking of requirements and the changes that will be made to them. That entire process is known as requirements management, or is part of requirements management. It is important to trace requirements both ways, that is, from the origin of the requirement to how it is implemented. And this is a continuous process, and so that's why it cannot be shown in a sequential way within these activities that you had just seen on the screen with respect to requirement engineering activities. So requirements management is a continuous process and must be done from the beginning till the end. And it becomes more formal as we proceed along away from the requirement solicitation and into the validation activities. What we have done today is that we have introduced requirements. We have talked about different kinds of requirements. We had a brief discussion on each one of them, and we have taken what is known as bird's eye view of what a software engineering, what a requirements engineering process is, because these are very detailed, long processes, and we have covered the whole discussion in one lecture. And this foundation was necessary for us to then continue our discussion on requirements with respect to quality assurance. And we will do that in the next lecture, and we will take up quality assurance aspects in the next lecture. But I have given you enough pointers even in this lecture to relate requirements to software quality assurance, to to relate requirements engineering process to software quality assurance, because for us, IT professionals, for software engineers, to develop high quality software products, we must start upstream, we must start with requirements. We must even start before requirements to understand what quality assurance is, and when we begin gathering requirements or start gathering requirements, we must think about developing a high quality requirement set. So we'll take up this discussion, enhance it further in the next lecture. Till then, Allah Hafiz. See you then.